Hello guys, welcome back to another video on the C# series. In this video, we are going to discuss about threads. Threads are the important topic in current trend in software development. So it is must have to understand what is meant by thread, how to implement thread in your program, what is the difference between threads and multi-thread, what is main thread, what are additional thread and all those related stuff. And in this video, we are going to discuss about all the things. First of all, we will be starting with what are all threads. Thread is nothing but a lightweight process. What is that? What is meant by process? So let's start from process and then we will go to thread so that you will be having a very clear understanding of what all those things. So the first thing is, what is process? Process is nothing but an instance of an executing program. Okay. Now thread is part of that process. There are many different threads available within a process. Okay. So now thread is a lightweight process that execute independently within the part of that process itself. We can have more than one number of threads within a process. Each thread execution will be having different call stack, but each and every thread within the process will be sharing same memory space, so that each thread can communicate with each other, so that sharing data between the thread will be very much easy. Hopefully you understood what is thread. Now what is meant by multi-thread? Multi-thread means if you are developing an application, if that application some operation need multiple threads, you have implemented some logic with multiple thread, then that application is nothing but multi-threaded application. What is meant by UI thread? We have discussed running Windows Form application. Let's recollect that. When I run the project, it actually open a Windows. Okay, that window running on a thread. Now what I do is, I am creating my own thread, another thread, and doing some operation separately, independently on the thread that I created. Since another work going on separate thread that I created, the main thread that runs the Windows Form doesn't have any impact of that. If suppose instead of creating another thread, if I execute the operation on the same thread, I mean the main thread, then user will not able to interact with the form till the work is completed. So that is how the difference between the main thread and then the additional threads work. Main thread is also called as UI thread, which actually execute the program. If you are creating any other additional threads and do some operation on it, that is nothing but multi-threaded application. Also, since you have another thread doing some work independently, the UI thread is free to interact with the user. There is no block of the UI thread since the work is taken care by another thread. That's the advantage. Now you have some understanding of what is thread, what is process, how thread works, and then what is mean by multi-thread, how the multi-thread things are working. There are many different types of threads available. I am not going deeper into all those things. I just tell the name: kernel thread, user thread, and then lightweight threads. These are all the threads available. I hope that now we have some clear understanding of the topics. I think it is a good time to start a simple thread program and then see how it actually works. First and foremost, here you can see I created one class called LearnThread and it has a main method. Now we are going to discuss all the thread related example within this class. So now what I am going to do is, let me use a thread class. In C#, we have a thread class, and keep that in mind. This thread class actually coming from system.threading namespace. So you can import that using system.threading namespace, so that you will have access to all the thread related classes. Now I have created one thread here, right? Equal to new thread. I haven't created, I am creating it. New thread. So in the constructor, we can pass any method that the thread going to execute. Keep that in mind. You see that this is the intro console application which we are using from the beginning. I am going to run this program. So what it actually does is, it creates or else it opens up with a console window. That's why we call this as a console window. Now along with that console window, I am creating one more thread to do some operation. It could be any operation. Okay. Now what I do is I have to create one more method because that's the method this thread going to execute. How will I able to do so? Just the ordinary method. You can create any method. Let's say static and it doesn't going to return anything. I'm just saying thread method. That's it. Now I can pass this thread method as a parameter to the thread that I created. I haven't written any logic within the method. I mean the new method that I create, I will be just writing it. But still, this is how we will be creating a thread. Whenever you create a new thread, right, that thread by default in unstarted state, which means this is the unstarted thread. I created thread, but I haven't done anything with the thread. You have to start the thread, then only the thread can able to execute it. So how will I able to start it? Just use a thread object and then you will be having lot of other methods. I will be using start. Now the thread has started, which means the thread is in running state. Now thread started. You can think that my main thread is there. Along with that I have one more thread. That thread execute this method. We are not blocking the main thread. So now what I am going to do is, let's do some work in the main thread. Let's say for I wanted to print something. Let's say example, I'm just going to change this to 1000. Okay, just printing some data just for sake of our example. Now this for loop work on the main thread, not on the thread that you created. Okay, we can consider this as a user thread and then the main thread. Now this code works based on the main thread. We don't have any interaction between the worker thread and then the main thread. Both are running separately. But what I'm doing is I just wanted to wait till my thread completes. Okay, this is the user thread. You can just think that this is a thread that I created. So calling it as a user thread, usually we call that as a worker thread. Now this worker thread needs to get completed. Chances are there this could get finished soon. So I don't want the program to terminate before completing this one. That is why I just use thread.join method. Now this call makes sure that the user thread is completed successfully and then it let the program to stop. That's what the thread implementation would look like. And keep that in mind, this is the very simple example of creating a one thread and then executing a logic in that thread. We can able to sleep the thread. I will be telling that in a minute. Before that, we do have one more way to run. That is nothing but multiple threaded application, where I will be creating a thread pool. Within that thread pool, I will be creating some 10 or 12 thread pools based on the core of my machine and then put it into that thread pool. So whenever I need any thread, I will take thread from the thread pool, do some work and then put it back. That's what the multiple threaded application usually does. Now this thread doesn't do anything, right? So what I'm going to do is I just copy this, put it here, and I don't want it to get executed. Let me change the main thread for loop to 100 and I wanted to make this to 500. So 500 time, obviously this is going to work. It takes more time to complete, but still that's fine for the example. Now what we can do is, let me try to make the thread sleep. Thread.sleep. How long you wanted to keep the thread to be sleep? I want the thread to be sleep for 1 second. So what we are doing is, for each iteration of this loop, I want thread to move to sleep state for 1 second. So that is what I'm doing it here. Always keep that in mind. Whenever you create a thread, the thread by default in unstarted mode. Then we will start the thread so that becomes to running state. Chances are there I will be using a thread.sleep or something to make it sleep. That's kind of a sleep state. And then I can do this join method to complete the worker thread to complete all of its work. Once all task or work is completed, then the thread go to stopper state. That's how usually it will be work. There are one more state is available, that is nothing but background, that usually do the background thread. That's how the threads are working. Now what I'm going to do is, I'm going to execute this program by pressing this run button and see how it actually behaves. You can see here, right? The worker thread is in progress, but keep that in mind. I have 98, 99 here, which is nothing but the for loop from the main thread. So main thread work is completed. Now worker thread work in progress, it is simultaneously executing. I should have created both to 100 or 200 so that you will be eventually look at it. You can see take more time to print, right? That is because of the thread state that I am changing in between. I am making it to sleep for a second and then iterate. Sleep, then iterate. Sleep, then iterate. That's why it is going so slowly. Let me stop that. I don't want to wait till then. Okay, I could have used some lesser time. Let's say I'm going to use this for 10, 15 and this too for 15. Let me make this main thread as well to sleep for once again for every iteration. Both thread going to execute for 15 times. So to differentiate between the worker thread and then the main thread, let me going to add a string so that we can easily differentiate that print statement. Worker thread. Now let me again execute this program by pressing intro. That's nothing but run button. You can see, right, both worker thread and the main thread work simultaneously, but both are working independently. This is how we can make use of the threads in our programming. Okay, I hope this example make you understand the difference between process, thread, how to create a thread and work with that. We'll be going to learn more about threads, asynchronous programming and parallel programming in our upcoming videos. Stay tuned for that. Till then, bye, take care.